Yo, Mr. Boy here. This is section 1.3, describing quantitative data with numbers. And one of the first things we want to do is when dealing with numbers, you want to always include center and spread, or what you're going to hear a lot of is what's called variability, because there's different types of variability that you'll deal with depending on if we're talking about mean or median. Mean is also known as the average. So that's all of the numbers added up divided by however many numbers there are. The median, on the other hand, is the number that is the middle of the value. So that is your midpoint, which we have seen in some of our dot plots and our stem plots up to this point. One of the best things to use for these types of numbers is what's called a box plot, and we'll get into that a little bit coming up. And it utilizes something called the 5-number summary. And the 5-number summary is what I like to call the 5-num sum. And that is the median, that is the quartiles, that is the max and the min values. All right. And we'll talk about what each of those are here in a second. So the first quartile is has about a fourth of the observations below, or 25% of the observations below it. The third quartile has 25% above it, so it has 75% below it. The median is quartile 2, and that is right in the middle at 50%. There is something called the interquartile range, and it's the range of the middle 50%. That's quartile 3 minus quartile 1. Pay very close attention to the check your understanding when we go through and we talk about all these little things. There's a lot of information with a lot of details being thrown at you right now in a small period of time. Outlier. So up to this point, we've talked about, hey, this could be an outlier. It looks like it visually, but I'm not 100% sure. So this is how you can figure out at what point do you go from being an acceptable data value, and then when's the line that you cross before you become an actual outlier. And the formula for the outlier is Q1 minus and then 1.5 times the interquartile range. Or to go the opposite direction, you take quartile 3 plus 1.5 times the IQR. Again, we're going to go through some check your understandings coming up to kind of clarify these types of things. We're also going to get into something called variance. Variance is like the square of the standard deviation. The standard deviation is the spread compared to the mean. So if the average is, whatever, 50, if the standard deviation is 5, that means if you're one standard deviation above, you would be at 55. And again, we'll kind of work through how you get standard deviation. And later on, when we start doing distributions, we'll show you visually what that looks like with that. But again, standard deviation and variance being the square of standard deviation, or if you have the variance to get the standard deviation, you do the square root of it, are things that deal directly with mean. Now, one of the things that we're going to try to take away from this is that the median is resistant to extreme observations or outliers. The mean is affected by large numbers or very, very small numbers. It can skew your data. And we'll talk again, like I said, specifically about those. So your mean and standard deviation go together. They're perfect for symmetric distributions that don't have major outliers, or what we're going to get into coming up, which are normal distributions. The median and the IQR are better descriptions for skewed distributions. And we'll again be going over the ins and outs of the why. But mean and standard deviation for normal distributions, mean and IQR for skewed distributions. And then finally, anytime that you're given numbers, you always want to plot the data. And we'll show you with the calculators and by hand how you do a dot plot. I think you'll find it pretty straightforward and to the point. Hey, it's Mr. Boyle.